Welcome to HFCL Time Machine. Past, present, future, all connected.
Let's step into today's chapter, where we explore how Hyderabad Airport reimagined connectivity for a new era of air travel and what it means for the future of smart airports, connected guest experiences, and digital aviation infrastructure.
It is quite a journey we have ahead today.
It really is.
Yeah.
If you are listening to this, I want you to imagine something. Imagine trying to physically relocate the entire population of the United States.
That is a lot of people.
Right. Over 330 million people.
Yeah.
But imagine moving them all through airport terminal doors in just a single year.
Wow.
You have to coordinate all their check bags, their connecting flights, their inevitable layovers, and, all their operational schedules, all within a 12-month window.
It sounds completely impossible.
It does, but that is actually the reality of modern Indian aviation right now. It is a logistical puzzle of just unprecedented scale.
Absolutely.
And to keep that massive machine running, you have an entire unseen world that operates parallel to the departure gates.
A world most passengers just walk right past, right?
Exactly. And today, we are unpacking a really fascinating case study on how the Airport Authority of India, specifically down in Hyderabad, recognized a massive technical bottleneck in that unseen world.
Right.
And they brought in HFCL to build an enterprise-grade digital nervous system to fix it. So joining me to decode the architecture behind all of this is our resident expert.
Always great to be here.
Before we start looking at the network cables and the cloud controllers, we really have to grasp the sheer gravity of the data load this airport was facing.
Yeah. I mean, to truly appreciate why the digital infrastructure in Hyderabad required a foundational teardown and rebuild, we first need to look at the macro forces acting on Indian aviation.
Right.
Because we are not just talking about incremental, year-over-year growth. We are looking at an absolute explosion in passenger mobility.
It's exponential at this point.
Completely. Let us isolate just the financial year of 2023. During that specific period, airports across India collectively handled a passenger traffic volume of over 327 million.
Okay, let's unpack this. 327 million people moving through security checkpoints, connecting to terminal Wi-Fi, and relying on digital displays.
Yeah.
That is just a staggering amount of human movement.
It really is. And out of that huge number, nearly 57 million were international travelers.
Oh, wow. Which brings a whole different set of needs.
Exactly. They bring their own complex set of data and connectivity requirements. But the real catalyst for upgrading the infrastructure is the trajectory we are on.
The speed of the growth.
Yes. If we look at a snapshot from October 2023, domestic traffic jumped 15% compared to that exact same month the previous year.
Wait, 15% in a single year?
Yes. That translates to an additional 20 lakh domestic passengers suddenly appearing in the system in just a single month.
That is unbelievable.
And meanwhile, international traffic surged by 23%, crossing well over 3 lakh passengers in that same window.
That level of month-over-month compounding growth,
Mm-hmm.
that puts immense stress on the physical infrastructure.
Oh, it creates a permanent stress test for the entire system. In fact, the International Air Transport Association, IATA, they project that by 2030, India is anticipated to surpass both China and the United States.
To become the largest.
To become the world's third largest air passenger market.
Okay, I have to push back here on our focus today, though.
Sure.
Because when you mention becoming the third largest passenger market in the world, my immediate thought goes to, building more runways.
Right. Pouring concrete.
Yeah, expanding the baggage carousels, putting up more air traffic control towers. But the Airport Authority of India in HFCL, they did not focus this specific high-density network overhaul on the main terminal.
No, they did not.
They targeted the airport's hospitality sector.
Yes, the guest houses and the hostels.
Right. And on the surface, that seems entirely peripheral to the main event of actually flying planes.
Mm-hmm.
Why are we focusing on guest houses and hostels?
See, it only seems peripheral until we redefine what an airport actually is.
Okay, how so?
It is not merely a transit hub where people just get on and off planes. It is a highly sensitive, localized command center.
Command center.
Exactly. The Airport Authority of India manages 137 airports across the nation, and Hyderabad serves as one of their most critical tech-forward nodes.
Right. Hyderabad is a huge tech hub anyway.
Exactly. So consider the operational reality of moving 327 million people. You have inevitable weather delays, complex aircraft maintenance schedules.
Things breaking down.
Right, and massive, constantly rotating crews of pilots, flight attendants, visiting officials, and VIPs.
Which means you have a massive population of critical personnel who basically need to be housed on site.
They absolutely have to be, because a fatigued pilot or a disconnected ground controller, that is a severe safety liability.
You cannot have a pilot scrambling for an Uber at 2 a.m. to find a hotel.
Exactly. So the airport's guest houses and hostels function as an essential operational lifeline. They ensure the human engine of the aviation sector actually functions properly.
I see.
What's fascinating here is the paradigm of what a guest house actually does has completely shifted.
It's not just a bed anymore.
Not at all. These spaces have evolved from simple dormitories offering a bed and a shower into high-stakes 247 workspaces.
Okay, so you have a 1990s infrastructure paradigm colliding with a 2024 data load.
Precisely. A pilot isn't just checking into a room to sleep anymore. They are logging onto their devices to download massive, highly encrypted weather packets.
Oh, right.
They need to update flight plans, stream interactive training modules. It requires heavy data.
And it goes beyond just the flight crews, right?
Oh, absolutely. Airport officials use these exact same spaces to manage demanding operational schedules, conduct secure, high-definition video conferences with headquarters, and coordinate complex logistics.
So the old definition of hospitality Wi-Fi, as just an amenity, something to let you scroll social media or maybe watch a movie, that's gone.
Completely gone. Today, it is absolute mission-critical infrastructure.
I imagine the legacy networks in these buildings were essentially buckling under that evolution.
Buckling is a mild word for it.
Because you have a massive density of users grouped into these concentrated spaces, all pulling heavy data at the exact same time.
Yes, but, the human user density is really just one half of the problem.
Really? What is the other half?
Another half is the invisible traffic. Modern facility management heavily utilizes the Internet of Things, or IoT.
Oh, of course. The smart devices.
Exactly. We're talking about smart climate control systems, automated check-in kiosks in the lobbies.
Right.
Digital access locks on hundreds of individual doors, and high-definition security cameras constantly monitoring the perimeter.
And all of those devices have completely different networking needs.
Vastly different.
I mean, a smart lock just sends a tiny, kilobyte of data to verify a key card, but it needs an instant zero latency response.
Right, or the door doesn't open.
Exactly. Meanwhile, a 4K security camera is continuously dumping gigabytes of video feed onto that exact same network.
And the old infrastructure was likely trying to treat all of this traffic exactly the same, which just causes total gridlock.
That is the exact technical bottleneck they faced. Balancing this massive influx of public user data, like the pilot's streaming video, with the private, secure operational data of the building's IoT ecosystem is incredibly daunting.
Because legacy routers just aren't built for that.
No, they simply drop data packets when they get overwhelmed, which leads to frozen check-in kiosks, offline security cameras, and disconnected personnel.
Which means AAI Hyderabad had to bring in specialized firepower. They couldn't just, install off-the-shelf commercial routers from a big box store.
Definitely not.
They needed to wire an entire hospitality complex to perform like a corporate enterprise data center.
That is a perfect way to describe it.
Which brings us to the hardware solution engineered by HFCL. How did they physically architect a network capable of handling that kind of sheer density?
They executed a really massive strategic infrastructure deployment. The physical backbone of this new network relies on 85 strategically positioned Wi-Fi 6 access points.
85 access points just for the hospitality buildings. Yes, distributed across the properties to entirely eradicate any dead zones.
Let's break down what that actually means, because Wi-Fi 6 isn't just a marketing term for faster internet, right?
No, the underlying mechanism is entirely different from older generations.
I like to look at older Wi-Fi generations like a delivery truck that can only take one package to one house per trip.
That is a great analogy.
Right, so if 50 houses want a package, they have to wait in line while that single truck drives back and forth 50 times. That is why old networks buffer when too many people connect.
It is an excellent way to visualize the latency issue. Wi-Fi 6, however, changes that routing mechanism entirely.
Here's where it gets really interesting, because it basically turns that same delivery truck into a multi-stop logistics vehicle.
Exactly.
It can load packages for 50 different houses, map out the most efficient route, and drop them all off simultaneously on a single trip. Upgrading to this is like upgrading from a single garden hose trying to water a whole golf course to a state-of-the-art automated citywide irrigation system.
I love that. And the technical term for that mechanism is OFDMA. It allows the access point to divide a wireless channel into much smaller subchannels.
Meaning it can talk to more devices at once.
Yes, a single HFCL Wi-Fi 6 access point can concurrently talk to multiple devices at the exact same millisecond.
Wow.
Because of this efficiency, one of these specific enterprise-grade access points can effectively disseminate bandwidth to up to 1,024 concurrent clients.
Wait, really? Over 1,000 devices talking to a single access point.
Over 1,000 without degrading the quality of service.
That is mind-blowing, and that completely solves the density problem for the flight crews, the laptops, the phones, and the hundreds of IoT devices all demanding attention at once.
It absolutely does.
But, setting up 85 of these high-capacity access points creates a massive power delivery problem.
It certainly can.
Because I'm assuming the airport authority did not want to tear open the walls of their guest houses to hire armies of electricians just to install 85 new wall outlets.
No. Tearing down walls in a 247 operational facility is rarely a viable option. You just can't disrupt the guests like that.
So how do you power them?
To circumvent the need for localized power drops, HFCL utilized 9 24-port PoE switches, PoE standing for Power over Ethernet.
Okay, PoE makes a lot of sense from a deployment standpoint.
Mm-hmm.
You are essentially hitchhiking electrical power onto the exact same Ethernet cable that is already carrying the high-speed data.
It is incredibly efficient. The power is supplied directly from the central switch room.
Which keeps everything neat.
It does. It doesn't just clean up the installation process by eliminating separate electrical wiring. It dramatically increases the resilience of the network.
How so?
Well, if the guest house experiences a localized power fluctuation, the access points don't reboot.
Oh, because they draw power from the center.
Exactly. The central switch room is backed up by heavy-duty, uninterruptible power supplies.
Which completely isolates the hardware from the physical environment of the hallway or the lobby. And that level of resilience points directly to AAI Hyderabad's core mandate, right? They operate on a strict zero-tolerance policy for downtime.
Zero tolerance, because as we mentioned, in aviation, downtime cascades.
Right. If a pilot in the guest house loses their connection and misses a dispatch update, the crew is delayed.
The flight misses its designated slot.
And then suddenly thousands of passengers in the main terminal are impacted.
The cascading effect is very real, but guaranteeing zero downtime in a wireless environment is notoriously difficult.
Why is it so hard with wireless?
Because wireless signals are incredibly sensitive. They bounce off walls, they suffer from severe interference when something as simple as a microwave is turned on.
Really? A microwave?
Oh, absolutely. And the signal degrades simply as humans physically move around the building.
So how do you guarantee zero downtime with all those variables?
To combat this, HFCL implemented self-healing and self-optimizing easy mesh technology.
Okay, the concept of a self-healing network sounds a bit abstract. How does that actually function in real time? I assume the access points are doing more than just blindly broadcasting a signal.
Oh, much more. They are acting as an active, localized sensor network. These 85 access points continuously monitor the radio frequency environment around them.
They are listening to the environment.
Yes. Let us say an access point in the west wing of the hostel experiences a sudden spike in physical interference, or perhaps it actually suffers a rare hardware fault.
Okay.
The Easy Mesh system immediately detects the rising noise floor or the sudden drop in performance.
So it maps a localized failure instantly.
And instantly compensates for it. The surrounding access points dynamically communicate with each other.
Like a hive mind.
Very much so. They automatically boost their signal transmission power to cover the physical gap left by the failing unit.
Wow.
And simultaneously, the system dynamically reroutes the active user traffic away from the compromised node and onto the healthy ones nearby.
It functions exactly like an autonomous immune system for the network infrastructure.
That is a great analogy.
The coverage hole is patched by the surrounding access points before a pilot's video call even has a chance to drop a single frame.
And that invisible adaptation is the absolute core of achieving zero downtime.
So, we have established that the physical hardware is incredibly robust. You have the Wi-Fi 6 access points managing massive density through subchannel slicing.
Right.
You had the PoE switches cleanly delivering data and stable power.
Yes.
And the Easy Mesh technology actively patching over interference. But an enterprise network can have the most powerful hardware on the planet and still fail miserably if the software managing it creates friction for the user.
Oh, without a doubt. The end user should never have to think about the infrastructure.
Exactly. If an aviation official has to spend 20 minutes navigating a clunky login portal just to check their email, the technology has failed its primary objective.
It absolutely has.
And I am assuming the IT administrators aren't physically walking around the property with a laptop, plugging into the ceiling to manually update the firmware on 85 different access points.
No, no. Managing a network of this scale requires a completely unified approach. HFCL brought the entire deployment under the control of an advanced, centralized cloud controller.
The cloud control. Okay.
This provides the IT staff with a single pane of glass, a unified, real-time analytics dashboard.
So they view the entire 85-point mesh as one single holistic entity.
Yes. If the IT team needs to push a critical security patch or adjust the bandwidth throttling or perhaps optimize configurations to handle a sudden influx of VIP guests.
They don't have to touch the physical routers.
No, they execute it globally from the cloud interface.
Yeah.
And the network absorbs the new configuration without dropping any active connections.
That significantly reduces the man-hours required for maintenance, which ultimately saves the airport authority a lot of money.
Huge operational savings.
But looking at the guest experience, one of the biggest points of friction in large facilities is just the sheer number of networks broadcasting.
Yes, the clutter.
You look at your phone in a hotel and see a dozen different names: guest networks, staff networks, admin networks, premium Wi-Fi. It's confusing.
HFCL completely collapsed that complexity by implementing a unified SID.
Wait, just one network name?
Just one. Regardless of whether you are a visiting VIP, a permanent staff member, or a connected smart thermostat on the wall, you see one single network.
That introduces a massive security challenge, though.
How so?
Well, if you put public guests and sensitive airport operational systems on the exact same broadcast network, how do you prevent a guest from, accidentally or maliciously accessing the back-end facility management service?
That is where the software really shines. The intelligence lives entirely in the authentication layer.
Okay, break that down for me.
When a device connects to this unified network, the cloud controller evaluates its specific credentials and securely routes its traffic into isolated virtual lanes.
So it sorts them behind the scenes.
Exactly. And to protect the data inside those lanes, the network mandates strict WPA2 and WPA3 authentication protocols.
WPA3 is the real breakthrough here for public spaces.
It really is.
Because it solves a massive paradox in IT security. Usually, if you want enterprise-grade security, you have to force users through incredibly complex, high-friction login processes.
Right. Multi-factor authentication, VPNs, all of that.
Exactly. But if you want seamless coffee shop-style connection, you generally have to sacrifice security.
Well, WPA3 bridges that gap beautifully. It utilizes a protocol called simultaneous authentication of equals.
Simultaneous authentication of equals. What does that mean in practical terms?
In practical terms, it means that even though a pilot and, say, an airport vendor might be sitting in the exact same lobby, connected to the exact same unified network,
Yeah?
their data streams are individually encrypted using completely unique keys.
So even if a bad actor is connected to the same access point, they cannot intercept or decrypt the pilot's traffic.
Exactly. It provides the frictionless onboarding of a public coffee shop network with the isolated, encrypted security of a private corporate enterprise network.
Which is absolutely essential when dealing with aviation logistics.
Completely essential.
Yeah.
But beyond security, the software also solves the mobility problem. As you noted earlier, these guests are highly mobile.
Right, they aren't just sitting at a desk.
No, they move from their rooms, down the long corridors, into the cafeterias, and out to the transport lobbies.
And on a legacy network, if I am on a high-stakes video conference in my room and I start walking down the hall, my phone will just desperately hold onto the access point in my room until the signal completely dies.
Yes, the classic sticky client problem.
Right, the call drops, my phone panics, it finds a new access point in the lobby, reconnects, and I have to dial back into my meeting. It is incredibly frustrating.
That is the traditional client-led roaming experience where the phone makes the decision on when to switch.
And phones are terrible at making that decision.
They really are. HFCL's solution utilizes the cloud controller to manage fast and secure roaming.
So the network makes the decision, not the phone.
Exactly. Because the controller has a real-time global view of the entire mesh network, it actively monitors your device's signal strength as you walk down the hall.
So the controller anticipates the degradation before it even happens.
Exactly. It actively maps your trajectory across the access points.
Wow.
Before the signal from your room's access point gets weak enough to impact your video call, the controller proactively negotiates a handoff to the access point in the hallway.
And how long does that handoff take?
This transition happens in a matter of milliseconds. You can maintain a live, high-definition video conference while walking across the entire campus, and the connection remains entirely seamless.
It behaves just like a cellular network, actively passing the baton from tower to tower, but it is entirely localized on a private Wi-Fi infrastructure.
Exactly.
That is a massive leap in usability. And I imagine the controller is also managing what type of data gets priority during that handoff, right?
That brings in the quality of service, or QoS policies. In a high-density environment, not all data is created equal.
Right.
The cloud controller intelligently prioritizes traffic based on predefined rules.
So it builds an invisible fast lane for the important stuff.
Precisely. If an airport official is downloading a critical dispatch update, the network ensures that packet of data takes absolute priority over a guest in the lobby trying to stream a 4K movie.
But the guest streaming the movie doesn't get kicked off.
No, both users remain perfectly connected, but the mission-critical operation never suffers from bandwidth suffocation. It is a brilliant integration of hardware capacity and software intelligence.
It really is.
If we connect this to the bigger picture, Ashish Jain, the Associate VP of Network Product Sales at HFCL, provided some excellent context on this specific deployment.
What did he say about it?
He pointed out that integrating the Wi-Fi 6 architecture with the centralized cloud controller was about prioritizing deep resilience and efficiency. This wasn't a project aimed at simply patching a dead zone in a hallway. It was about showcasing advanced adaptability.
So what does this all mean? It fundamentally reshapes the baseline standard for what connectivity should look like within an airport ecosystem.
It demonstrates that when you properly integrate advanced technology, you can facilitate highly secure, high-volume communication across an expansive, physically demanding landscape.
And do it without placing any technical burden on the end user.
Exactly. The result is increased guest satisfaction, higher productivity, and a fully future-proofed operational landscape for AA Hyderabad.
When we pull back and look at the tangible results, the impact is just undeniable. The physical dead zones have been completely eradicated by the sheer density of those 85 Wi-Fi 6 access points.
Completely gone.
The IT administration has been streamlined through the cloud controller, which heavily reduces their operational costs. But most importantly, the actual human experience is transformed.
The friction is entirely gone.
Faster internet speeds, secure roaming, and prioritized bandwidth. All of that translates directly into higher productivity and reduced stress for the aviation professionals relying on those exact facilities.
And because the Wi-Fi 6 standard allows for such massive concurrent connections, up to 1024 devices per point,
Right.
this infrastructure is completely future-proofed.
It has to be with those growth numbers.
Exactly. As passenger numbers push toward that massive 2030 projection, and as AAI adds hundreds of new automated IoT devices to their buildings, this network will absorb the scale effortlessly without degrading performance.
For you listening, this is the vital takeaway of today's deep dive. When you're operating one of the fastest-growing aviation markets on the planet, the invisible infrastructure working silently behind the scenes has to be just as agile, secure, and robust as the actual commercial airliners taking off from the runway.
You absolutely cannot build a 21st century aviation hub on a 20th century digital foundation.
Exactly. These guest houses and hostels are the critical pit stops for the human engines of the aviation industry. And HFCL has ensured those pit stops operate with absolute zero friction.
And looking at that achievement leaves you with a really highly provocative question regarding where this technology goes next.
Oh, where it goes next? What do you mean?
Well, we have spent this time analyzing how a localized, highly dense hospitality network can utilize Easy Mesh to autonomously self-heal.
Right.
We have seen how a cloud controller can optimize traffic in real time to manage thousands of simultaneous data-heavy connections, blending public user friction with enterprise-grade isolation.
All while maintaining absolute zero downtime. It operates perfectly as a digital metro city.
Exactly, which leads to the bigger picture. If we can perfect this level of invisible, resilient, and highly adaptive digital infrastructure within the complex, high-stakes environment of an airport hospitality hub,
Yeah.
how long until the broader smart city infrastructure of our entire daily public lives transitions to this exact model? Imagine our metropolitan transit systems, our downtown commercial districts, and our emergency service grids running on this exact kind of invisible, self-optimizing nervous system.
That is incredible to think about.
Yeah.
Because the required technology is not conceptual anymore, and it is not years away.
No, as the deployment in Hyderabad proves, the architecture is already fully functional today.
That is a profound thought to walk away with. We are essentially watching the blueprints for the fully connected automated cities of tomorrow being drafted, deployed, and stress-tested right now inside the corridors of airport guest houses. And that brings us to the end of this chapter in the HFCL Time Machine. Until next time, stay connected to what's next.
Welcome to HFCL Time Machine. Past, present, future, all connected.